So once we get done with hardness, there are other different ways to see how things will break. We talked about our universal testing machine, which is a static test. We know that static means doesn't move at all. In this case, the static test of the universal testing machine, the UTM, is most definitely a slow moving test. We saw that our string test, the stretch of the string took almost 2 minutes to break the string. In the Charpy test, what we're going to be doing is it's sort of a crash test. We're going to take a particularly shaped and notched material. This material has already been notched. If anybody has chopped wood before or chopped down a tree before, you know one of the methods is to chop out a notch and then hit it from the other side. What's going to happen here is a particularly shaped specimen is going to have a particularly shaped notch cut out of it so that it breaks evenly and in a certain direction, and then we're just going to hit it with a hammer. But instead of hitting it with a hammer from a person, from a lumberjack swinging it, the swinging hammer is going to be from a machine, and then depending on how far this hammer falls, that will tell us when the specimen actually breaks. So what we can do is we can measure how far up, if you will, this hammer needs to be lifted on this pendulum swing. The hammer then lets loose, and then you can see whether it breaks it or not. You can do all kinds of calculations to see which specimen was harder and which didn't make it. Here's an example of a Charpy impact testing material. Again, the notch that we showed before in this cartoon kind of looked, at least in my mind, kind of large. In reality, it's kind of small. Again, what we're trying to do is just make it so that when you hit this, it doesn't dent it. It really does break it. And I guess this notch helps it to break right along this line right here. They go ahead and place this on pins and then pull back the hammer and then slam down and watch it break. And I think we have a video coming up of some students using that. And here's a picture of what that material looked like after it was broken. So you can see that we're going to hit it with a pretty heavy solid metal hammer on this side. It's going to snap or break inside here. Pardon me, I have a phone call. We'll let that roll. It's going to snap or break right through the center here. And then you can see that it's not a very nice cut. We're not slicing it like a karate chop with a very sharp knife. It happens to be a pretty rough snap or break. So let's push this button over here. And yeah, let's look at some grad students, or these might even be undergraduate students. It looks as if they're at a school that has a material testing lab or material engineering lab. And in addition to having UTMs, they also have a Charpy testing machine. And you can see the size of this thing. Let me get out of here real quick. Push this button and take a look at this video.
This ain't KLEHM Hall. Let's get out of here. Now this is KLEHM Hall. KLEHM Hall has material testing. Let's go on in.
Alright, hey, welcome back to the Materials Testing Lab, everyone. My name is Brian, and we're going to be talking about the Charpy Test today. Now this just evaluates the toughness of material. Today we're going to be using this, which we've constructed in the production lab. We make sure our notch mark is in there and it's at the appropriate size. First thing we want to do though is load our hammer. So we're going to pull back, lift up. It's pretty heavy, but now that you've heard that noise, you know it's latched in the machine correctly. Now we're going to take this here and we're going to bring it all the way to the left. And this is going to measure how many foot-pounds the material can handle. We're also going to remove this bucket. We don't want anything obstructing the hammer when it does come through. And we're going to take our material, our test specimen, and these tongs here, and we're going to go load it up into the machine. Now we're going to want our notch mark facing towards me for this test. Before I do anything, I want to tell you about our brake. So when the hammer is going, you're going to want to hit this brake to slow everything down after testing is conducted. So we're going to release our latch string. And hit our brake. And you can see there, this is our result. So it looks at about 239. And that's it. That's our Charpy test.
All right, that was pretty impressive. So you can see right away the way I described the Charpy test was probably inaccurate. That particular Charpy instrument, rather than having the handle sort of go up to a certain height and then adjust it, they put it up to a standard height, and then they measured how far it went, how high it went after it broke through the sample. So it broke through the sample, and then depending on how much energy it took to break the sample, that would remove energy from the hammer pendulum. And then if it removed a lot of energy, it wouldn't swing up very high on the other side. And if it removed just a little bit of energy, then it would only swing up a little bit. So that's how that particular Charpy instrument works, which is kind of cool.